When dealing with an FPE panel replacement, the ideal approach for ensuring complete safety is to replace both the FPE panel and the FPE outside disconnect. While it's true that not every FPE product suffered from the same level of issues as their panels, the disconnect was likely manufactured around the same period and might share similar underlying safety concerns. If the decision is made to replace only the panel, it is critical to ensure that the new panel is fully compatible with the existing FPE disconnect. This means carefully verifying that the amperage and the ampacity ratings of the new panel precisely match those of the existing disconnect. Crucially, the replacement work should only be performed by a qualified and licensed electrician. Their expertise is essential to guarantee that the installation is carried out properly and safely, adhering to all applicable electrical codes and safety standards. It is important to acknowledge that not all FPE panels inherently pose an immediate hazard, and many have been operating safely for many years. However, the documented potential for failure and the significant safety concerns that are generally associated with FPE panels lead to a general recommendation for their replacement when they are found in a home. Home inspectors frequently recommend replacing FPE panels, and insurance companies might also strongly suggest or even require their replacement as a way to mitigate potential risks. The cost to replace an FPE panel can vary significantly depending on factors such as the amperage of the panel, the complexity of the electrical system, and the local labor rates. Given the information, the most prudent course of action is to replace both the FPE panel and the FPE outside disconnect. This will maximize safety and eliminate any potential for future issues related to the older disconnect. It is always best to consult with a qualified electrician for a comprehensive assessment and recommendations tailored to the specific circumstances of your electrical system. The electrician will be able to evaluate the condition of the existing disconnect, assess its compatibility with the new panel, and provide expert guidance on the most appropriate and safest course of action. Electrical panels and disconnects are critical components of a home's electrical system. The electrical panel, often called a breaker box, serves as the central distribution point for electricity throughout the home. It receives power from the utility company and distributes it to various circuits, each of which powers specific areas or appliances. Inside the panel are circuit breakers, which are safety devices designed to protect the electrical system from overloads and short circuits. When a circuit breaker trips, it interrupts the flow of electricity to that circuit, preventing potential damage or fire. The disconnect, also known as a service disconnect or main disconnect, is a switch or circuit breaker that allows you to completely shut off power to the entire electrical panel. This is important for safety during electrical work or in emergencies. It is typically located near the electrical panel, either inside or outside the house. The disconnect ensures that all power can be cut off from the panel quickly and easily. The amperage rating of an electrical panel and disconnect is a critical specification. It indicates the maximum amount of electrical current that the panel and disconnect can safely handle. For example, a 200 amp panel can handle up to 200 amps of current flowing through it at any given time. Exceeding this rating can overload the panel and potentially cause a fire. When replacing an electrical panel, it is essential to choose a new panel with an amperage rating that meets the home's current and future electrical needs. The disconnect must also have an equal or higher amperage rating to match the panel. Compatibility between the new panel and the existing disconnect is also crucial. They must be designed to work together safely and efficiently. A qualified electrician can ensure that the new panel is properly sized and compatible with the existing disconnect, or recommend replacing the disconnect as well if necessary. Electrical codes and safety standards play a vital role in ensuring the safe installation and operation of electrical panels and disconnects. These codes, such as the National Electrical Code or NEC, provide detailed guidelines for electrical work, including panel replacements. Electricians must follow these codes to ensure that the installation meets safety requirements. Regular inspections can also help identify potential electrical problems, including issues with the electrical panel or disconnect. A qualified electrician can perform these inspections and recommend any necessary repairs or replacements. Replacing an electrical panel is a complex task that should only be performed by a qualified and licensed electrician. It involves working with live electrical wires, which can be dangerous if not handled properly. An electrician has the training, experience, and tools to safely disconnect the old panel, install the new panel, and make all necessary connections. They can also ensure that the installation meets all applicable electrical codes and safety standards. When choosing an electrician, it is important to select one with experience in panel replacements. Ask for references and check their credentials to ensure that they are qualified to perform the work. A reputable electrician will also provide a written estimate before starting the work and explain the process in detail. If an FPE panel is identified in a home, it is generally recommended to replace it due to potential safety concerns. FPE panels have been known to have issues with circuit breakers failing to trip during overloads or short circuits, which can increase the risk of fire. Replacing an FPE panel with a modern panel can significantly improve the safety of the home's electrical system. When replacing an FPE panel, it is also a good idea to consider replacing the disconnect as well, especially if it is also an FPE product. While not all FPE disconnects are as problematic as the panels, they may still have similar underlying issues. Replacing both the panel and the disconnect provides an added layer of safety and peace of mind. If replacing only the panel, it is essential to ensure that the new panel is compatible with the existing disconnect. This means verifying that the amperage ratings of the panel and disconnect match and that they are designed to work together safely. An electrician can help determine compatibility and recommend any necessary upgrades. The cost of replacing an electrical panel can vary depending on several factors, including the amperage of the panel, the complexity of the electrical system, and the local labor rates. It is important to get multiple estimates from qualified electricians to compare pricing and services. While replacing an electrical panel can be a significant expense, it is an investment in the safety and reliability of the home's electrical system. The information provided is for general guidance only and should not be considered as substitute for professional advice from a qualified electrician. Always consult with an electrician for specific recommendations and guidance related to electrical work. Electrical panels are typically rated for specific voltage levels, such as 120/240 volts or 277/480 volts. The voltage rating indicates the maximum voltage that the panel is designed to handle safely. It is important to ensure that the voltage rating of the new panel matches the voltage of the home's electrical system. Circuit breakers are designed to protect electrical circuits from overloads and short circuits. When a circuit breaker trips, it interrupts the flow of electricity to the circuit, preventing potential damage or fire. Circuit breakers come in various sizes, measured in amps to match the specific needs of each circuit. For example, a 15 amp circuit breaker is typically used for general lighting and receptacle circuits, while a 20 amp circuit breaker is used for kitchen countertop circuits. Grounding is an essential safety feature of electrical systems. It provides a path for stray electrical current to flow back to the source, reducing the risk of electric shock. Electrical panels and disconnects must be properly grounded to ensure safety. Grounding involves connecting the metal parts of the electrical system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a low resistance path for electrical current to flow back to the source in the event of a fault. Arc fault circuit interrupters, or SIs, are a type of circuit breaker that provides enhanced protection against electrical fires. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. When an SI detects an arc fault, it quickly interrupts the flow of electricity to the circuit, preventing fire from starting. SIs are typically required in bedrooms and other areas of the home where arc faults are more likely to occur. Ground fault circuit interrupters, or GFCIs, are another type of circuit breaker that provides protection against electric shock. GFCIs are designed to detect ground faults, which occur when electrical current flows through an unintended path, such as a person's body. When a GFCI detects a ground fault, it quickly interrupts the flow of electricity to the circuit, preventing an electric shock. GFCIs are typically required in bathrooms, kitchens, and other areas where water is present. Surge protectors are devices that protect electrical equipment from voltage spikes which can damage or destroy sensitive electronics. Voltage spikes can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the protected equipment. Surge protectors come in various forms, including whole-house surge protectors that protect the entire electrical system and plug-in surge protectors that protect individual devices. Aluminum wiring was used in some homes built in the 1960s and 1970s. Aluminum wiring has been known to have issues with overheating and causing fires. If a home has aluminum wiring, it is recommended to have it evaluated by a qualified electrician. The electrician may recommend replacing the aluminum wiring with copper wiring or installing special connectors that are designed to be used with aluminum wiring. Knob and tube wiring is an older type of wiring that was used in homes built before the 1940s. Knob and tube wiring is not grounded and can be a fire hazard. If a home has knob and tube wiring, it is recommended to have it replaced with modern wiring. Electrical permits are required for many types of electrical work, including panel replacements. Electrical permits ensure that the work is performed safely and according to code. A qualified electrician will typically obtain the necessary permits before starting the work. Electrical inspections are performed by local building officials to ensure that electrical work meets code requirements. Electrical inspections are typically required after a panel replacement or other significant electrical work. A qualified electrician will schedule the inspection and ensure that the work passes inspection. Maintaining an electrical panel involves keeping it clean and free of obstructions. Dust and debris can accumulate inside the panel and cause overheating. It is also important to ensure that the panel cover is securely in place to prevent accidental contact with live electrical wires. If there are any signs of damage or corrosion inside the panel, it is important to have it inspected by a qualified electrician. Troubleshooting electrical problems requires a systematic approach. Start by checking the circuit breakers to see if any have tripped. If a circuit breaker has tripped, reset it. If the circuit breaker trips again immediately, there may be a short circuit or overload on the circuit. If the problem persists, it is important to consult with a qualified electrician. Electrical safety is paramount. Always turn off the power at the disconnect before working on any electrical circuits. Use insulated tools and wear appropriate safety gear such as rubber gloves and safety glasses. Never work on electrical circuits when standing in water or on a wet surface. If unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. Extension cords should only be used temporarily. Overloading an extension cord can cause it to overheat and start a fire. If there is a need for a permanent electrical outlet, it is best to have one installed by a qualified electrician. Light fixtures should be properly installed and maintained. Ensure that the light bulbs are the correct wattage for the fixture. Replace any damaged or cracked light fixtures. Smoke detectors are essential safety devices that can save lives. Smoke detectors should be installed on every level of the home and outside of sleeping areas. Test smoke detectors monthly and replace the batteries at least once a year. Carbon monoxide detectors are also important safety devices that can protect against carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas. Test carbon monoxide detectors monthly and replace the batteries at least once a year. Be aware of the location of underground utilities before digging. Contact the local utility companies to mark the location of underground utilities before starting any digging projects. Digging into underground utilities can be dangerous and can cause service disruptions. Avoid overloading electrical outlets. Plugging too many appliances into a single outlet can overload the circuit and cause a fire. Use power strips with surge protection to protect electronic devices. Keep electrical cords away from heat sources and water. Heat can damage electrical cords and water can create a shock hazard. Replace frayed or damaged electrical cords immediately. Do not attempt to repair electrical cords yourself. Use child-proof electrical outlets to protect young children from electric shock. Child-proof electrical outlets prevent children from inserting objects into the outlets. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical shocks. Supervise children when they are around electrical appliances. If you have any concerns about the safety of your home's electrical system, contact a qualified electrician for an inspection. An electrical inspection can identify potential hazards and ensure that the electrical system is safe and up to code. Remember, electrical safety is everyone's responsibility. By following these safety tips, you can protect yourself and your family from electrical hazards.